Let's go through the sample test for Chapter 6. It says sketch the curves. And you want to do a fairly decent sketch or you may not get things correct. You can type it into your calculator, but this is 4 over x. So if I put in 1, 4 over 1 is 4, minus 1 is 3. If I put in 2, 4 over 2 is 2, minus 1 is 1. And if I put in 4, 4 over 4 is 1, minus 1 is 0. So it goes something like that. Okay, and that's F. And now G, if I put in 1, I get 1 minus 2, which is minus 1 squared, 1 fourth. So 1 minus 1 fourth is 3 fourths. If I put in 2, that's 0 over 4, which is 0. So I get 1. And then if I put in 4, 4 minus 2 is 2, squared is 4, over 4 is 1, 1 minus 1 is 0. This is a parabola, it's upside down, so it's looking something like that. Okay? So, set up the integral to find the area enclosed by the curves. Well, that would be this slice right in here. Not a very big slice. We're not rotating it or doing anything creative here, so then determine the area. So the area under G would be, we'd have to go from 2 to 4. We'd find the area under G, and that would include some of this, and then we'd have to subtract under F. So the integral would be from 2 to 4 of G minus F and you could type this into your calculator. I'm going to do a little algebra here and see if I can get this to work out. So it's going to be from 2 to 4. I've got 1 minus a minus 1, which is 2. I have minus x squared minus 4x plus 4 divided by 4. And then I have minus 4 divided by x. And so I have the integral from 2 to 4 of, I have a minus x squared, I have a plus 4x over 4, which is just x, and then I have, oh, this x squared is over 4 too, so it's minus 1/4 x squared. Don't make mistakes there. I have minus a minus plus 4x over 4, which is x. Then I have 2 minus 1. 4 over 4 is 1. So 2 minus 1 is 1. And then I have minus 4 over x. These are all added or subtracted, so I can split them up. And I'm going to get the integral of this, which will be increase by 1 and divide by 3, so it's going to be minus x to the third over 3 times 4, 12. Integral of x is plus 1/2 x squared. Integral of 1 is plus x. Integral of minus 4 times 1 over x is minus 4 ln x. And all of this evaluated from 2 to 4. So I would put 4 in here, and I'd get 64 over 12 reduces to 16 over 3 plus 16 divided by 2 is 8 plus 4 minus 4 ln 4, all of this minus putting 2 in here, I get 8 over 12, which is 2 over 3. Putting 2 in here, I get 2. Putting 2 in there, I get 2. And putting 2 in here, I get minus 4 ln 2. And I could do some simplifying, but that's if I work it out longhand. I'm okay if you do this on a calculator and get the decimal approximation for what this all would work out to be. Okay, number 2. Sketch the area, set up the integral, and determine the volume of the solid by rotating the area in the first quadrant. So first quadrant of y equals cosecant x. So y equals 1 over the sine of x. The sine goes up to 1 and back down, and it hits at pi. Its highest place is at pi over 2. The cosecant is the reciprocal. The reciprocal of 0 is undefined, so there's an asymptote. There's an asymptote. This is 1, and the cosecant curve would be looking like that. And I want you to find the area of the volume that's created by rotating this about the x-axis. So pi over 6, there's pi over 162636, so pi over 6 is about here. And 2 pi over 3, so this is 1/3, 2/3, right about there. And rotate this about the x-axis, so it would be something that looks like this. So we're going around. So now, I need to find, let's see, this is rotated this way. Probably the easiest would be to do the disk method, because rings get really tricky when you got stuff like this. So a disk is what I would expect you to do on this one. And so it's pi integral of r squared minus the inside, but there's no inside to take away, so dx. And so let's see, yes, because the slice would be a thickness of dx, so it's dx. The radius is from here to there, which is y, and y is cosecant, so it's going to be pi integral from pi over 6 to 2 pi over 3 of cosecant x squared, the radius squared dx. And the antiderivative of cosecant squared is negative cotangent x, evaluated from pi over 6 to 2 pi over 3 and times pi. Pi, antiderivative from there to there. So I'm going to get pi, and cotangent is cosine x over sine x. Cosine, let's get our unit circle out here, of 2 pi over 3, 1/3, 2/3. Cosine is negative 1/2. Sine is square root of 3 over 2, so that's minus 1 over the square root of 3. Putting that in there, and it's minus already, so that makes it plus. And then we have to, we got this minus, and now we've got a, and it's minus, so it's going to actually be plus. Now we got to put in pi over 6, which is right here. And the cosine there is square root of 3 over 2, and the sine would be 1/2. And so that cancels, and I get the square root of 3, and that's a positive number. And we're got minus a minus, so that's positive. So all this is times pi. And there's the exact answer. Or you could have done it with the calculator right here, as long as you know how to type that in. And that would be pi integral of 1 over sine of x, whole thing squared, dx. Evaluate, and then do that integral, which is cotangent. If you have to do the cotangent if you do the integration, but you can also just type this in and do it from there to there and get the area, or the volume of this. Okay, number 3. This one, I give you a place to graph, so let's go ahead and graph on here. X plus y equals 3. And I'm going to put my coordinate system sort of in the middle here. I can see that this is going to go through plus 3 in the x and plus 3 in the y. And for intercepts, so x plus y equals 3. Looks like that line-ish. Y equals x plus 1. So y-intercept of 1, slope of 1. Looks like that. Y equals 1. Looks like this. Graph the 4 equations. So I graph my 4 equations. Then, well, that's the 4 points there. That should be, I wrote here. Set up the integral for the equation to find the volume of the solid created if the area was rotated around y equals minus 1. So minus 1 is here. So if I make that the axis, and this is the enclosed area, it's 2 above the axis, so it'll be 2 below. So it would end up here. So it would go round like this and come back up. So it says set up the integral equation that would find the volume of the solid of the area, rho pound minus 1, using the disk method. So disk method, I have to slice perpendicular to the axis. So if I slice it here, it's going to be governed by this. The inside radius is going to be governed by that line, and the outside here. But over here, it's going to be governed by this. So I'm going to have to do it in 2 separate integrals if I do the disk method. And there is an inside, so the disk method is pi integral of large R squared minus small r squared. So it's going to be pi integral, and I'm going to have to do it in 2 pieces. And a slice would be a dx, so it's dx, I already said that. The large radius is going to be, well, up to this line. That's y from here, the x-axis, to the curve. But I have to add 1. So the radius is going to be y plus 1 squared, and that's the y from this equation. Dx evaluated, and I'm going to do that for x going from 0 to 1. Then I'm going to have to do the rest of the way from 1 to 2, it would be pi integral of 1 to 2, and now that it's going to be, again, y, but it's the y of that equation, y plus 1 squared dx. Now I have to get the y's in terms of x, so I would have to go pi integral from 0 to 1 of, see, the y, the first one was this, so it's x plus 1, so it's going to be x plus 2 squared dx plus pi. Now it's y plus 1. Well, y in this is 3 minus x, and if I add 1 to that, it's going to be 4 minus x squared, going from 1 to 2 dx. So there's it set up for part B. C, set up the integral equation to find the volume of the solid created by if it's rotated around -1. Doing the shell or ring. Ring and shell are the same. Some books call it shell, some call it ring. So I called it the ring. So now we have to do rings, which mean slice parallel to the axis. And so the thickness would be dy, and it's 2 pi r d times the height, which is in that direction, which is going to be the difference in the two x's, the x from the one taken away from the x of the second. So it's going to be an x minus an x, and we're going to have to figure out what those are, which ones, dy. And we're going to integrate that from from it's dy, and so y is going to go from 1 to 2. So we're going to have 2 pi integral from 1 to 2 of r. The radius of this ring is the y value plus 1 more. That's the radius of the ring. It's 2 pi times the radius times the height times the thickness. Now the height is going to be the x from this graph, which is this one, and that's 3 minus y, minus the x from this graph, which is y minus 1, dy. So we're going to get, let's see, this is all added or subtracted here, so I'm going to get 3 minus a minus 1, which is 4, and I'm going to have minus y, which is minus 2y, times y plus 1, integrated from 1 to 2 of 2 pi dy. So then I could multiply this together and find the integral. It says use calculus methods to solve one of the integrals. So now I want you to not use the calculator, but use calculus. So you can either multiply these together, integrate them, or multiply that out and evaluate that integral, and multiply that out and evaluate that integral. You can do either one, and I presume you can do that, but I'll go ahead and, well, I guess I should probably do both of them for you. We should get the same answer, so this will be a good check on whether I'm too sleepy to be doing this or not. Okay, so we have pi integral from 0 to 1 of x plus 2 squared dx plus pi integral from 1 to 2 of 16 minus 8x plus x squared dx. antiderivative. So we got pi. I can't combine these two because they got different limits. Antiderivative of that is 1/3 x to the 3 plus 2x squared plus 4x, evaluated from 0 to 1, plus pi 16x minus 4x squared plus 1/3 x squared, evaluated from 1 to 2. This comes out to be 1/3 plus 2 plus 4 minus 0 plus pi times, this will be 32 minus 16 plus, oh, this is third power, 8/3 minus, putting in 1, I get 16 minus 4 plus 1/3. And this turns out to be, we've got a lot of fractions here, so I've got 1/3 plus, so that's 6 and 1/3. All of this is times pi, so I can put these together. 32 minus 16 is 16, minus 16 is 0, so these are cancel out. And I've got 8/3 minus 1/3, which is 7/3. But I didn't make 8/3 minus 1/3, 7/3. Oh, and I got a 4, don't I? Minus a minus 4. Let's see, I do this. I did. That's 16 minus 16. They cancel, so I still have the minus 4. Minus the minus 4 is plus 4. So I got 4 and 7/3. So I have 10 and 8/3. 8/3 is 2, so 12 and 2/3 pi. All right, let's do the other one and see if I get the same thing. So I do 2 pi, integral from 1 to 2. This would be minus 2y squared plus 4y minus 2y is plus 2y. And then I have plus 4. So I have 2 pi 2 minus 2/3 y to the 3rd plus y squared plus 4y, evaluated from 1 to 2. So if I put 2 in there, that's 8 16/3 minus 16/3 plus 4 plus 8 minus, putting 1 in there, it's minus 2/3 plus 1 plus 4. So I have 2 pi times, see, let's do this, that's 12 minus 5, which is 7. 16 minus 16/3 plus 2/3 is minus 14/3. Did I get everything? 12 minus 5. Minus 16/3 plus 2/3, 14/3. That's 4 and 2/3. So 7 minus 4 and 2/3, which is 2 and 1/3, times 2 is 4 and 2/3 pi, and that's not what I got over here. Okay, I think this one might be right, so I need to go back and check here, my arithmetic. And you can check also, so that's x squared plus 4x plus 4 squared, 16 minus 8x plus x squared, 1/3 x to the third, 2x squared plus 4x, 16x minus 4x squared plus 1/3 x cubed. And if I put in 1, I get 1/3 plus 2 plus 4. I put in 2, I get 32. 2 times 2 is 4, times 4 is 16. 8/3 plus minus 1 in there is 16 minus 4 plus 1/3. So 32 minus 16 is gone. And I get 8/3. 8/3 minus 1/3 is 7/3. So I get 4 and 7/3. And over here I get 6 and 1/3. So I still get 10, 11, 12, and 2/3 pi. Okay, so maybe I did something wrong in the setup here, because I'm not getting the same answer in both of those. So let's do the disk again. The large radius is y plus 1 on this, minus the small radius, which is, oh, I didn't do the minus the small radius. I forgot all the minus the insides. The small radius is 2. So it's 2 squared, or 4. So I'm taking away, it should be a minus 4 in there. And on this side, it should be minus 4. I forgot to do the minus 4s. Blah! I am so sorry. So this becomes, there's a minus 4, minus 4, minus 4, and all these. So there should be a minus 4 in here. So that cancels that 4. So this is completely gone. And there should be a minus 4 in here, which makes this 12. Okay? So now, this is 12. So this is gone. So I get 2 and 1/3 times pi. And over here, this should be 2 times 12 is 24. And over here, it should be 12. So I have 24 minus 16, which is 8, minus 12, which is minus 4, and then I have plus 4, which they all cancel out. Minus 12, let's see, 12 minus 4 is 8, and 24 minus 16 is 8, so the 8's cancel. So I just have the 8/3 minus 1/3, so I have 7/3. And that is 2 and 8/3. 2 plus 2 is 4 and 2/3 times pi. And that does match the other answer. I forgot to do my minus the r squared for the inside. Apologize for that. Okay, number 3. Find the formula for the volume of a hemisphere. So a hemisphere, a sphere, has a radius of same radius all the time, and they're calling it r. So this is r, but this is also r, and that's r, etc. They're all capital R. So derive the formula. So I'm going to take a slice. I'll do it right here. And if I put my axis right here, this could be the x and this could be y. And so the radius is in the x direction. The height is in the y direction. And so the volume of the slice, let's see, that would be dy thick, because I'm doing y in this direction. So it's going to be pi r squared dy integrated from y would go from 0 to r. But this radius is x, but I need to have it in terms of y, so I got to solve for x. And I can use this triangle to solve for the x. See, x squared plus y squared equals r squared. So x squared would be r squared minus y squared. So this becomes the integral of pi r squared minus y squared from 0 to r dy. I could solve for x and call it x squared equals r squared minus y squared, and then I could take the square root, but then I'm going to have to square it right back for putting it in for x squared, the radius squared. All right, let's finish this up. R squared, don't fall for r squared being a variable. It's not. It's a constant. It's the radius. So if I integrate r squared, it's r squared y. If I integrate y squared, I get minus 1/3 y cubed. All of this is times pi, and we're evaluating from 0 to r. So I put r in here, so r squared times r is r cubed, minus, put r in here, and I get 1/3 r cubed. Put in 0, I get nothing, and so all of this is times pi. So this is 3/3 minus 1/3 of r cubed, which is 2/3 r cubed times pi. The volume of a sphere is 4/3 pi r cubed, so 2/3 pi r cubed is a hemisphere, and we've just got the correct formula. Okay, turning this over. Next one. So determine the work done by a person standing on a roof. The building is 5 meters high, lifting a bucket that is 20 kilograms with a rope that is 0.05 kilograms per meter. So if the rope is 5 meters, it's 5 times this. But when we pull it up, it'll be less rope out here still to be pulled up, and so it'd be the shorter distance times this will give the mass of the rope. So we're going to have to do, we've got the weight that the mass that we're going to be picking up, let me say it correct, will be 20 kilograms plus the mass of the rope, which will be 0.5 kilograms per meter times the length of the rope it's there. So I'm going to call the length of the rope x, and so I'm going to take it times x, and x is going to start at 5 and go to 0, or we can do it the other way around from 0 to 5. Doesn't really matter. We'll get a number 0 to 5. So when it's 5, we've got the whole rope out. When it's down to 0, we'll only have that little bit. And so this would be mass, because this is in meters, and we cancel the meters. So we got mass and mass To get the force, we have to make it be a weight, so we have to take it times kilograms meters per second squared, which is 9.8 kilograms, acceleration due to gravity, per meters per second squared. So kilograms, excuse me, 9.8, I'm getting tired, meters per second squared times the kilograms makes a newton. That would be the force times the distance. Well, we're going to move it up a distance of dx, and then we'll keep adding the distance dx. So this is going to be the distance, and this will be mass times acceleration, which makes mass times acceleration is a force. So this is set up with the right limits and everything, so we're going to get 20 times 9.8 plus 0.5 times 9.8x dx integrated from 0 to 5. This is just a constant, so it'll be 20 times 9.8x integrated plus, integrate this, is going to be 0.5 times 9.8, 0.05. I just realized I forgot a 0. 0.05 times 9.8 times x squared over 2, evaluated from 0 to 5. And so I'll put 5 in here, and I'll get 20 times 9.8 times 5 plus 0.05 times 9.8 divided by 2 times 25 x squared, minus, put 0 in, I get nothing. And so this should be the amount of work. It would be newtons times meters, so I could say the units are Newton meters, but that's also a joule. So I'd have to work that number out. Okay. Number 6. So let's do this one. We're going to pump the work pumping the water out of the top of a full cone. It would make sense to either put the coordinate system 0 down here or at the top. You can do it either way. And I'm not sure which way you would like to do it. I think I'll just put it at the top. I bet most of you would put it at the bottom. Maybe I should put it at the bottom because most of you would. Okay, so I'm going to call that X, and I'm going to call that Y. And we're pumping water, so I'm going to take a slice of the water. Oh, and it said the base has a diameter of 6. Don't get that messed up. So that means the radius is 3. And a height of 9. And those are both in meters. So my slice, since I've made y go this way, would be dy. And it would be pi r squared would be dy, would be the volume of the slice, times the density, and we'll do the mass density of water, which is 1,000 kilograms per meter cubed, but this would be meters cubed. So now I got kilograms. Well, then I'd have to multiply by 9.8 to make it newtons, a force, and then we'd have to talk about the distance we have to lift it. So if I put 0 here, this is y, so the distance I'm lifting it is going to be 9 minus y is this distance. So times 9 minus y. The distance I lift it, this turns the mass into weight, and this is the volume that gets rid of the density denominator. This is volume. So everything's good except for r. And r's here, which is x. So somehow I've got to get an equation for x in terms of y, because I'm doing dy. Well, if I look at this, this point would be 3, 0, 3 in the x, 0 in the y, and this point would be 0, 9. So I could write the equation of the line through those 2 points. See the slope, that's minus 9 over the change in x is plus 3, x plus the y-intercept 9, and minus 9 over 3 is minus 3x plus 9. That's y. But I need to solve for x, so I'd subtract 9, so I get y minus 9 divided by a negative 3 is x, and that's what I'd have to square and put in for the r. Let's do it another way. Let's do it with ratios. So I've got a triangle here and the big triangle. I'm trying to find x, so I'd write x over 3, let's say, equals the leg to the leg as the leg is to the leg, and this leg is 9 minus y over x. Let's see, wait a minute. I did x from the little triangle to 3, so I got to do the long leg, 9 minus y, to the long leg, which is 9. So if I multiply both sides by 3, this reduces to 1 minus y, this 1 minus 1/9 y. If I take it times 3, I get 3 minus 3/9 y, which is minus 1/3. So I get, what did I do wrong here? Oh, yes, minus 1/3 y, that's minus 1/3 y, and this is plus 3. So I could use, x could also be 3 minus 1/3 y. I can use that for r, or that. I could divide the minus 3 into both of those, and that turns into this. And I can use either one of those for those. And I'd have to integrate this. This is all constant, so I put the integral there, put that in there, and y has to go from 0 to 9. So I would have 9,800 pi antiderivative of 3 minus 1/3 y squared times 9 minus y dy. 0 to 9, we can type this into the calculator and integrate from 0 to 9 times the 9,000 pi. I can integrate this. This would be 9 minus y minus 2y plus 1/9 y squared times 9 minus y, so I'd have to take 9 times all of these, which would be 81 minus 18y plus y squared. Then minus y times all those would be minus 9y plus 18y minus 1/9 y to the third. And I can put the minus 18 and the minus 9 and the plus 18. Oh, these cancel. So I'd just have minus 9y. So I'd have 81 plus y to the third minus 1/9 y to the third, y squared plus y to the third. And I'd have to integrate it, and I can do that. evaluate from 0 to 9, and I should get the same thing the calculator says for here. And I'm allowing the calculator on now. I'm not going to work that one out. Okay, let's go to the next one. Suppose you have a dam shaped like this. It's 100 feet across. It's 80 feet on the bottom. It's 40 feet deep. And it's filled to 5 feet below the top. So, and it's water, so it's 62.4 pounds. Since I'm doing feet, I'm going to do pounds per feet cubed. I'm going to take a slice of the water. We'll take one right off the top. And it's going to be at some depth. Let's just call it x. So if I take it times x, and that would be in feet, that cancels one of them. So now I'm feet squared. So I got pressure, pounds per square foot, times x, which is in feet. So this is the pressure on this slice. The slice, if I'm making x go this way, this would be dx. So the area of this would be however long that is. It's in the y direction. Probably most of you would put the coordinate system right in the middle. So this would be x over here, and this would be another same as this, so it would be double x. And this would be y. Well, I better make this be y this way and x this way, because I made x go up and down, so I'll make this be x and this be y. Okay, so we've got, let's make this be x like I had it. Make this be y, dy, so dy, dy, and it's going to be 2x long. X plus x long. Lift it, or the pressure is going to be times y. That's how deep it is. And we're going to integrate this for y going from, if I'm putting 0 for y right here, well, let's put 0 for y right here. Doesn't matter. I'll put y down here. So I'm going to do y, lift the water, or find the pressure for y equals 0 to 35. And the only thing I got to get rid of is the x. So I got to figure out how to write that with an x. This point, if I make y go this, I said make x go this way, and y go this way. Going too fast here, make it nice and clear. X this way, y this way. This point would be 50 and 40 high. This point would be 40 and 0 high. If I put y up here, that changes the y heights on it, but I put the x-axis down here. So the equation for x is what I'm trying to find. So I'm going to write y equals slope, and I've got x this way, y this way, so I can do my equation normally. The change in y, it goes up 40. Over the change in x, it goes from 40 to 50, so that's 10. X plus the y-intercept. I don't know the y-intercept, so I have to put in a point, so I'll put in 40 for x, and this is 4 over 1, so that's 4 times 40 is 160, so I'd have to do minus 160. If I put 40 in, 160, that's 1,600 divided by 10 is 160, minus 160 is 0 for the y. If I put in 50 for the x, I get 2,000 divided by 10, which is 200, minus 160, which is 40. Now I have to solve for x, because that's what I want to replace. Add 160, so it's y plus 160, and this is 4x. So that is 4x. So I divide by 4 and I get 1/4 y plus 40 equals x. That's what I can use for the x. All right. I'm going to do that one again a little differently, just so that you can see how it might be easier to do it another way here. I'm going to again let this be y, but I'm going to put the origin up here, call that x. So I'm going to call this y and this x. Can't make up my mind. I'm sorry about that. I'm going to do a slice. If this is x, this is dx. And we're going to have x go from, if I put it here, it's going to start at 5 and go to 40. And it's going to be the 62.4 times the depth it's at, which is going to be x. That'll be the force times the force density, so it's per meter cubed, so I got to get the volume of no, I'm doing pressure here. So that's the pressure, and got to get the area of the slice. The thickness is dx, and the width is going to be y times 2. So 2y, y plus y, 2y, times the thickness, dx, that's the area, times how far down it is, x, and I'm going to do it times this. And let's make this be the positive x down here, so x goes from 5 to 40. Make it positive 40. Okay. Now I still have to find y. And what makes this a little different is this is now a y-intercept. Makes the equation a little easier. This is 50 in the y direction and 0 in the x direction. And this is 40 in the y direction and 40 in the x direction. So the change in y is 50 over 40. Let's see, no, this is 0 in the x and 50 in the y. So yes, so the change in the y goes down. This is the positive x, so it goes from 50 to 40, so it's negative 10 over the change in the x goes from 0 to 40, which is 40, times x plus the y-intercept, 50, equals y. And if I solve, that is solved for y, what I want. That's what makes this a little easier. I don't have to do all this solving for y. I can put that in for y, and I'd have x times 2 times negative 1/4 x plus 50 from 5 to 40 of 62.4. And you can type that in the calculator and work it out, or you can multiply the 2x times that, 2x times that. That makes it an easy integral to do, and work out the answer. I made that one messy. I'm sorry. Again, I'm tired. Okay, the next one. Center of mass of an object has a linear density of this. So as we go down this object, whatever it is, let's say it's a rod, from 0 to 4, the linear density is 1 plus sine of 0.1x. And to find the center of mass, you find the density times how far down that density is, adding it up, over just the density, the total mass. And so the dx is canceling. This is in mass divided by whatever the mass is, divided by the length, times the lever arm where it's located, divided by the density times where it's at. So this is what we need to work out. So it's going to be, and we're going to go from 0 to 4. So we get x times this, so x plus x sine 0.1x integrated from 0 to 4 dx over 1 plus sine of 0.1x dx integrated from 0 to 4. And that should give us the center of mass. And it should be a number somewhere between 0 and 4. Okay? Now, I'm going to pull out my calculator. And first thing I'm going to do is, I guess, clear all these equations. I didn't get them all cleared. There's more down here. Okay. So the first thing I'm going to do is just get a picture of what the density looks like. 1 plus sine of 0.1x. So and we're going from 0 to 4, so zoom decimal should be all right. And this looks like, let's make sure I got it mode, is in radians, yes. Almost looks like a line. So it's denser on this end than at end, so the center of mass should be closer to this end. It's more density on this end than on this end. Okay, so now let's find where the center mass is. So we do this equation times x. So I'll come down here and do vars y variables y1 times x, that's what this was, and integrate it. So second, calculate the area on that. So I need to be on the red curve, calculate it from 0 to 4, and that area, that answer is 10.0999 whatever, over, now we're going to do it for the other one, which is the first equation I put in. So I'm going to go second, calculate 7, and now it's the blue equation, and that's the one I want to do. I want to go from 0 to 4, and that amount is 4.789.3. So I'm going to take and divide those. 10.0999 divided by 4.789.3, and I get 2.0 1. So it's just past the middle, 2.108 is the center of mass. But once again, center of mass on a linear thing is just the density times how far out it is. Density times, if it's a linear, it's just times dx, gets the mass times the distance, gives you a kind of how much is twisting it over the total mass, and we get the center of mass. All right, and number 9. So I'm asking you to determine these if they're possible. So the first one's the integral from 3 to infinity of 2 over the square root of x dx. And what I'm expecting you to do is say, okay, this is an improper integral because of the infinity. So I have to go limit as a goes to infinity and put a in place of that. So 3 to a of 2 over the square root of x dx. Work on this part. Do the antiderivative. See, that's 2x to the minus 1/2. X to the square root is a half, and it's in the denominator, so it's minus. Integrated, so I'm going to add 1 to the power, so it's going to be x to the 1/2 divided by 1/2, so it's 2. X to the 1/2 divided by 1/2, which makes 4x to the 1/2 when I integrate this. So I haven't done the limit yet, I've just done the integration. 4x to the 1/2 means square root of x. Evaluated from 3 to a. So let's write that. Haven't done the limit yet. As a approaches infinity, I'd put in the a first, so I get 4 square root of a minus 4 square root of 3. And now I look at this and see what happens as a goes to infinity. Does this approach something or blow up? Well, the square root of infinity gets infinitely large, and so therefore this diverges. It's divergent. It diverges. Okay? So let's go to the next one. So it doesn't look like there's a problem here. There's no zeros that cause to be. Oh, wait a minute. 2. So the integral from 2 to 3 of 1 over x minus 2 squared dx, if I put 2 in there, I get division by 0. So 2 is the problem. So I need to write the limit as a goes towards 2. That's the problem, child. Of the integral from a to 3 of 1 over x minus 2 squared dx. Now, if we do a u substitution, 1 over x minus 2 squared, if we're just trying to integrate that, if I let u equal x minus 2, du would equal dx, and so this would be 1 over u du, 1 over u squared. So the antiderivative of u to the minus 2, I'd add 1, so it'd be u to the minus 1 divided by minus 1. So the minus 1 makes it negative, and the u to the minus 1 makes it 1 over u. So it's 1 over x minus 2. So this integrates to limit as a approaches 2 of minus 1 over x minus 2 evaluated from a to 3. So I'm going to do that first because I haven't done the limit yet. So it's going to be the limit as a approaches 2 of, put in 3 and I get minus 1 over 3 minus 2 minus a minus, which is plus 1 over a minus 2. And I want to, now I've got this all evaluated, clear down to this. Now I'm going to put 2 in. Well, this is a constant. That's not a problem. But 2 in here, I still have division by 0. So that's going to make this fraction get really large. So this also diverges. Okay?